Let's talk about how to graph a polynomial function. To graph a polynomial, the first thing that we can do is identify the roots, or the x-intercepts, and their multiplicities. Using the multiplicities, we can determine the behavior at each root. So for instance, whether the graph should bounce off of that root or whether it should go through that root, and things like that. Finally, we can use the leading coefficient to determine the y-intercept and the end behavior of our polynomial. So let's look at an example. Find the graph of the function f of x equals 1/2 times x minus 1 quantity squared times x plus 2. So here we're given the function already factored for us. So it's fairly easy to identify the intercepts from a factored form. So because of this first factor, we know that x equals 1 is one of our zeros. So let's identify our zeros. We have x equals 1, and because of the factor of x plus 2, we have a 0 of x equals minus 2. And again, we got these just by setting these factors equal to 0 and solving for x. So if x minus 1 equals 0, then x equals 1. If x plus 2 equals 0, then x equals minus 2. So those are our zeros. So let's put those on our graph. We know that there's one at x equals 1 and at x equals minus 2. Okay, so that's step 1. Now let's pay attention to the multiplicities. We know that because x equals 1 has multiplicity 2, because of the power there, we know that at x equals 1, either our graph is going to, it's either going to bounce like this, or it's going to bounce like that. It's not going to go through the root at 1. That's what happens when we have an even power. We're either going to bounce from above or bounce from below. So something like that. We're not exactly sure what's going to happen there. At x equals minus 2, we know that the graph is going to cut through the x-axis at minus 2 because this has an odd degree. It's degree 1. So it's going to sort of cut through in a linear fashion, either like this or like this. So one of those behaviors is going to happen. So that's step 2. And finally, let's look at the leading coefficient and use that to determine our y-intercept. So our y-intercept, well, remember our y-intercept is when x equals 0. So when x equals 0, well, we get minus 1. Let's just plug it in and see. So f of 0 equals 1/2 0 minus 1 squared times 0 plus 2. Well, 0 minus 1 is minus 1, but then it gets squared, so it becomes positive. So we just get 1/2 times 0 plus 2, which is 2. So 1/2 times 2, which is 1. So that's our y-intercept, is at 1. So let's plot that point. Okay, now that gives us enough information to determine what behavior is happening at 1 and also what's happening at minus 2. So this should allow us to fill in the gaps and graph our function. So because we know our graph goes through here, we know that this has to be an upward facing curve at 1. So it's going to bounce off the curve like this. And because we don't have any other roots over to the right, we know that this is just going to increase from there. And now at minus 2, we know that it can't cut downward like this because that would mean that our y-intercept were negative over here. So we know it has to cut up through minus 2. So something like that. And now we've connected the dots, and over to the left here, this continues down negatively because we don't have any other roots to the left. So this is roughly what our picture looks like. And now we can see what the actual graph looks like, and that's similar to what we had earlier. So again, we see that the curve cuts through -2, it has a y-intercept at 1, and then it bounces off the curve at x equals 1 and comes back up from there. So that's the graph of our function. Now let's take a look at another example. We're asked to find the graph of the function f of x equals -1/18 times the quantity x minus 2 squared times the quantity x plus 3 squared. So again, we're going to find the zeros of this function, plot them, look at the multiplicities of the zeros to help determine the behavior, and then finally we'll find the y-intercept to help us connect the dots. So to start with, we'll find the zeros. So from this first factor, because we can set it equal to 0, if x minus 2 equals 0, we find that x equals 2 is one of our zeros, and it has multiplicity 2. And from the other factor, if we set that equal to 0 and solve for x, we find that x equals -3 is our other zero. So let's start by plotting those. We have x equals 2 here, and x equals -3 here. Now let's pay attention to the multiplicities. X equals 2 has multiplicity 2, so it's either going to be a positive U shape or a negative U shape. And similarly, at x equals 2, which has degree 2, we're going to have a positive U shape or a negative U shape. Now let's find what the y-intercept is. The y-intercept is what we get when x equals 0. So we have that f of 0, in this case, is -1/18. Well, when x is 0, we get -2 squared. And when x is 0, we get 3 squared. So when we simplify, we get -1/18 times 4 times 9. So that's 36 over -18, which comes out to be -2. So that's our y-intercept. And now we have enough information to fill in the gaps. We know that each of these is going to be a downward U shape at each of these zeros because they have to connect with our y-intercept at -2. So we know it's the downward U there and the downward U there, and then from there it continues downward. So this isn't a perfect drawing of it because our shape should be a little bit smoother than this, but that's a rough idea of the behavior of our polynomial. It's going to come up from the left, bounce off at -3, hit our y-intercept at -2, go back up to 2, and then continue back downwards as x increases from there. So that's a rough picture of what our function looks like. We can see what the actual graph looks like. And that's what our actual graph looks like. So similar to the sketch that we drew, just a little bit smoother.